data handling. I think that's what we're doing right now. Mr. Lambert is the sports master at Princeton Sports Academy. He collected the following data from his second team soccer players. What is data? Data is a raw information. It is not analyzed. It is not arranged. None of that stuff. So it's just information collected, right? So then we have data handling. So when we handle data, we are analyzing, classifying, all those things to the data when we are data handling it. All right. So in 4.1.1, it says state whether the above data is discrete or continuous. I'm going to be a little bit detailed here, just in case you don't get to revise in detail. So I'm going to be a little bit detailed. Here's what happens with data. First, we collect the data, right? The method is first we collect the data. And when we collect the data, we develop questions. So when this guy was collecting this data, he had to come up with questions he could ask the learners. Like, what is your weight? What is your height, right? What's your name? You know, and supporting questions like, what's your name? Unless it was anonymous, and then he wouldn't ask. He'd be like, maybe ask them, where do you live? Things like that. Or what is your age? So that would be supporting questions, just in case he needs them to understand his data better. So those are the questions we would develop to ask the questions. Now, when we are asking the questions, we have a method that we use or instruments. We call them methods or instruments. So these are instruments to collect data or methods to collect data. Right? So what we do is we say, okay, fine. We are going to ask, we have questions now, and we're going to ask them. How are we going to ask them? There's 3 ways we can do this. We can interview the people by talking to them mouth to mouth or through the phone, whatever, face to face, and we talk to them. That is an interview, number 1. And number 2, we can use what we call a questionnaire. So we write our questions down, and the person will answer below the questions or next to the questions. That is a questionnaire. Or we could use observation, right? So each method has advantages and disadvantages. For example, observation, you cannot know the weight of a person or height of a person by just looking at them. These are measurements. You have to measure it, right? So it's either you ask them because they might know, or you measure them yourself, right? So that's the thing. So we cannot observe, or because observation is looking. So that one's already not going to work here when we collect this data. And then once we've used the methods, then we classify our data. So with the classification of data, we also have 2 groups where we classify our data. The data can be categorical or it can be numerical. Right. So what is categorical data? Categorical data is data that is in groups, like such as color of eyes, color of race of people, what else? The country of origin, people separated, color of cars separated in colors, and all of that stuff. So, and we say there's pink cars here, there's blue cars here, there's green cars here. You see? That is categorical data. But numerical data is data where we are either counting, which is whole numbers, or we are measuring. 2. Now, they say that if we are counting the data in numerical data, it's called discrete data. You have to just memorize the stuff. And if it's measuring data, then we are doing a continuous data. It's called continuous data. Both these are numerical data separated in their own way, in their own characteristics. So discrete data is data that's counted. It's under numerical. Continuous data is data that is measured, and that's other numerical as well. So the question we're going to do here, I love this. By the way, in the beginning, when I started teaching maths literacy, I used to struggle with the whole continuous and numerical and categorical. I couldn't understand it. But if you give yourself time, you'll be fine. Okay. The first question here says, state whether the above data is discrete or continuous and give a reason for your answer. You see here, there's weight that is measured and there's height that is measured. So what we're doing, we are measuring. These are measurements. So this is continuous data. It's not, we're not counting the number of people. We are getting their measurements for their weights and their heights, and that is continuous data. Lovely, isn't it? Why are we saying continuous data? Because here data is measured. Get your 2 marks and you move on with your life, right? Okay, so we're going to look at 4.1.2, which says use the table 3 and the answer sheet to to draw a scatter plot representing the heights and weights of the soccer players. So you need to know the types of graphs. A scatter plot is that you plot the dots but you don't join them. You know, see how in like broken line or in a line graph or any of those where we plot the dots and then we join them, right? Here we don't. We just plot the dots and leave them alone. I do have here an answer sheet. So what you do here, it says use this table. So what you do, I'm only going to do like 2 points. 48 kilograms goes with 1,58. So here's our height and here's our weight and here is our thingy. So 48 kilograms is on this line here. You see, the thing is, what we don't learn is that this whole line is actually 48 kilograms. So the whole part here is 48 kilograms. So now we just have to go find where the height is, and the height is 1.58. So this whole line here represents 1.58 meters, right? So where they meet is where this one learner is, right? So that would be our scatter plot. So I'm just going to remove this so that you can see this is has nothing to do. It's just me trying to find the point. Okay, so try not to be too bright. Okay, so this is here. And then the next one is 55 kilograms. So I'm just going to look for 55. 55 is between 54 and 56. So it's somewhere in the middle there. Between these two will be our, make sure you use a ruler so that you are exactly in the middle. And then we will have the height, which is 1.56. 1.56 is right there. So they meet right there. See? And that is our graph. So you continue and say I can start this way and say 1.62. This is the whole line for 1.62. And now I know my graph is going to be somewhere here. I just have to find where they meet, which is 50 kilograms. And then they meet 1.62 meets there. And that is our area there. So that's where they meet. That line meets that line, and where they meet is my dot there. So I'm not going to do the whole thing because it's repetitive now. 4.1.3, use your graph 4.1.2 to describe the correlation between weights and heights of the players. First, we have to remind ourselves what is correlation. So the correlation is a relationship. So they're asking, what is the relationship between the players' weights and heights, right? So why the reason this is done in a scatter plot is because the weight of another learner has nothing to do with the weight of another learner. They're not connected. It's not like when one learner's weight increase, the other increase. No, there's no relationship. There's nothing. They just don't go together. So there's no relationship there between the two. So that's what correlation mean. I think the only problem would be understanding what correlation mean. Correlation is a relationship between whatever these things that are talking about. Okay, state one advantage of displaying the above data in a scatter plot. Well, it's easy. It's easy to see it, right? It's easy to it's easy to identify the information that you're looking for, to compare the heights and the weights. It's very easy when you're using the graph above. So it says calculate the mean weight of the players rounded off to the nearest whole number. I'm feeling a little lazy and a little sleepy. I'm going to go to sleep after the mean. So 4.1.5 mean is equal to total of all the data that is being asked, of data, divided by number of data. So we have to count the data. How many is the data? Number of data. Now I'm just going to go back to the question, making sure I calculate the right one. Calculate the mean of the weight, right? So we're going to look at the weight of the players rounded off to the nearest whole number. So the rounding off is the answer. So we first need to find the mean first, and then we're going to round off the mean. Okay, so the weight here is 48 plus 55 plus 50 plus 58 plus 62 plus 60 plus 52. What if you run out of space? What do you do then? You go down and you say plus 69 plus 76 plus 84 plus 70, and then this whole thing, make sure you underline at the right space, divided by everything. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, divided by 11, and then you find the total there, and then you divide by 11. First I'm going to calculate the total there, and I'm going to write it down, and then I'm going to divide by 11, and then I'm going to do the rest afterwards. So that'll be 682. Then I'm going to divide by 11. And the answer is 62. And that is our mean. The average weight is 62. Now, what I'm going to remind you when it comes to mean is that when you're looking for the average, right, you're trying to see where a lot of people's weight is concentrated. When you have something called an outlier, somebody who's lying outside. So let's say we have these weights here which are between 40 and what is the highest? 70, right? And then suddenly we have somebody who has 122 kilograms or 160 kilograms, right? So that is a bit outside. This will actually make the mean average inaccurate, right? Because it's going to lie to us. It's going to give us obscure information because it's going to use this person and bring that average weight close to that person, but this is just one person. So the mean would then not be the good idea. Let's say we had here someone who is maybe 2 kilograms. Same thing, outlier, right? So no, it doesn't help. Oh, the highest is 84, and it doesn't help. So that's what we do. We look at that when we're calculating the mean, like, can we use the mean to calculate, to find the average here? And if we have an outlier, normally it is not a good idea to use the mean. It would be better to use maybe the median or the mode.